New people have arrived at the sofa.
Yes.
Lynn Houthuys,
Yeah.
professor at VUB
Yeah,
in artificial intelligence.
indeed. Yes.
Okay. Geraint Wiggins and Felipe Gomez. I'm all ears, so I'm just gonna ask what you do, how long you have been with this AI lab, and what your expertise is.
Yeah. So I haven't been with the AI lab for very long. I started in March, but then immediately went into pregnancy leave. So I basically started in August.
Okay.
I'm doing mostly research on multi-model learning or multitask learning, multi-view learning, basically everything where you combine different models to make a better model, basically. So, for example, if you would want to do some prediction with images and text, you will need different encodings. So you will need basically different models to then simultaneously do the same task.
Okay.
That's basically my...
But like the brain works together with all the brain regions.
Yeah, exactly. The brain does that basically automatically, but we have to train the networks into working together.
Well, a few millions of years of evolution have done their work, and we don't have that time in computer science, of course.
No.
Geraint.
Yeah, so I'm the professor of computational creativity, which means that I am interested in the aspects of AI that do with creative behavior.
Yeah.
So not just in poetry or music or whatever, but also in science and maths. Humans are fundamentally creative animals. That's what allows us to invent all the stuff we're using here today. I'm interested in the kind of AI that specifically focuses on the ability to invent new things.
Okay.
And that actually takes me back to first principles at the moment. So we're looking at new ways of doing inference in a different kind of mathematics, which is used in quantum theory, as it happens, in the hope that this actually is going to give us a better handle on the way we can model human creativity.
Mm-hmm. When did you start in artificial intelligence?
Oh, a very long time ago. In 1984. Yep, in the University of Edinburgh, where I did my PhD. So that's a very long time ago. And I started at the VUB here in 2018.
Okay. See, you've seen the entire evolution since the 80s until now.
Since the 80s. Not quite the entire, I'm not quite that old to see the entire evolution
you
of AI.
weren't there at the Dartmouth conference.
No, I think they're all dead now. Most of them anyway. Yeah.
Okay.
Great.
And Felipe?
So, Felipe Gomez, I did my PhD at the AI Lab. Now I have my own company. I'm the CTO of the company. I co-founded with my colleague Pierre, and we do bionic technology. And my task is to implement AI in this bionic technology. We focus on amputees, so people that have lost their limbs. And we are building this new technology to ensure that these devices can adapt to the user. When you are an amputee, you buy something that is fixed, that is not adaptable. Mm-hmm. And if you buy some other bionic technology, the control or the way you control this is also fixed. So your gait changes all the time. You get injured, you change your gait. You're happy, you change your gait. And our vision here is to ensure that our devices adapt to the user. So we learn that we profile the way they walk. We profile them, we ensure that the user then feels like they have their limb back. And that's basically our vision and what I'm doing today.
So it's prosthetics with active engines in there?
Yeah, indeed. So the actuators that can change the gait or can change the behavior or the way the user works.
Mm-hmm. And where is the AI part? Is it machine learning? Does it?
It's a little bit of everything. So we actually touch upon different parts of AI. So yeah, of course, there is some part of machine learning because we need to understand the intention of the user. So there's a lot of sensor data, real-time data that needs to be taken into account to do a detection. But there is another part of reinforcement learning, for instance, which is a type of a field of AI that uses the information of the environment and then try to adapt based on what the environment wants to do. Or in this case, the agent would be the user, and he wants to do a particular intention, and then the agent will try to figure out what's the best control for the user to do that intention. So we combine these two fields of AI to provide a better processes to the user.
If you succeed in building an AI that can predict the intention of someone, please send it to me. It will save marriages if you actually can predict the intention of your partner.
That
would be very good. How is it trained? What data do you need?
Well, basically, for now, because we are a medical device, so medical devices, you are very constrained. And something that I wanted to point out is that we do a different kind of AI. It's an embedded AI. You have to take into account that most of the AI that you see in the news and in the social media are models that are trained in GPUs and in big servers and so on, but we do not have the possibility of that computation. We have to be in real time, and it has to be in a very small chip with very little processing power. So it's also a big challenge.
You can't send it to the cloud and then wait for it to return. And
we could, but then because we are a medical device, then there is risks that need to be taken. So we have to ensure that we also implement safe AI, make sure that the amputee is always safe at each moment, which makes it even more complex.
Yeah.
So there's a lot of complexity. And for now, what we do is we sensorize the bionic foot, or for now our focus is on foot, but it's any limb. We sensorize it, and then with these sensors, we start doing the detection. And then with the feedback of the user and other markers, we can use that to ensure comfort. And then that's how we push our models to optimize the comfort of the user.
So you moved from academia to startup world, as many people do in AI. How is startup life? Is it stressful or exciting?
Definitely exciting. I love it. It's stressful, but it's very motivating because my passions have always been between AI and robotics, and if you can help someone with it, it's great. And that actually takes you. It's stressful. You need to go fast to market, and but at the same time, you know that I have the possibility to do something for this world, and to bring the latest technology actually to the market. So there is a lot of excitement from different sides.
Yeah, hope it works soon, and we can see your inventions running around in the world, literally, so to speak. Back to academia. You make different models communicate with each other.
Yeah.
But first, because I ask everyone, when did you start in AI? What was the first thing you did?
I did also computer science, and then I went into the industry as a consultant. But I didn't really like doing that, so I thought, let's start studying again. And there was this master after master AI, and I thought, why not? I liked the AI courses I had in my computer science, so why not go further in AI? And it was a very good decision because I really liked it.
What year was it? The AI master?
I think I did it in 2014.
2014.
Yeah. So a while back, and then afterwards I got the option to do my PhD there, and I really liked it still some more. And then I went into, I actually started teaching in a hogeschool, international hogeschool, where I was doing also research with industry, which is has its complications, but it's also very fun. But I did miss the academic world, so I went back, and now I'm here.
You crossed each other.
Yeah, indeed. Yes,
indeed.
On the road.
Yeah.
Now you're also teaching?
Yeah, exactly. I'm teaching mostly, a lot of the courses in the first year, and then some master courses. But I'm teaching, for example, data and society, where we actually go into like the societal, struggles with AI, not only struggles, but also opportunities that AI can bring.
But that's one amazing part about the field.
Yeah.
Is that you go from matrix mathematics to ethical implications and society.
Yeah.
In one if
Yeah, exactly. And you kind of need to know a little bit about everything. If
You can't leave it to the mathematicians.
Yeah, no. Yeah, no. You need to know a little bit. I mean, although my research focus is on the very theoretical side, I need to know about societal implications, and I also bring that into my research. I work a lot with robustness and fairness, and it's important that you keep thinking about how this will work actually when you actually implement it. How will it work, and what are the moral dilemmas, and how can I deal with it?
Yeah. What did the AI boom do for students? Is it a different profile? Is it just more, or?
Well, it has its upsides and downsides, I would say. I mean, we have a lot of students, so that's good.
Yeah.
It did reach way more people, which is a very good thing. But it also gave a little bit of the idea, I think, for lots of students that AI is kind of magic or something. Like, just put some data and buy some magic and poof.
Every event that I go to about AI starts with the same talk, and it's demystifying AI, because people get wild ideas.
Yeah, it is. And students sometimes also come with these ideas, and they also don't always realize how much mathematics is behind it, for one thing. But most of them are actually very enthusiastic and really want to learn more. So for now, I haven't really met any students that weren't enthusiastic, at least.
And the role of the AI lab in the studies or in the enthusiasm for students?
Well, I think it's very nice that we have the bachelor in AI here. So it's the only bachelor in Belgium it's completely AI. And I think one of the nice things is that it's very multidisciplinary. So they really get also courses on language and on cognitive science. And I think that's very good, because they will once they graduate, they will really know about a lot of things and can really make very good contributions in AI with all that knowledge. So
Yes, they are very welcome here.
Yeah.
And then AI and creativity. Well, shall we start with 2 hours of semantics about what creativity is?
Well, that is usually where the discussion starts, it has to be said. I mean, it's the same thing about the demystifying of AI. So intelligence is famously what we call an ex post phenomenon, right? You can't point to a particular property of a system that makes it intelligent, or to detect its intelligence. You can look at what it does, and then you say, I count that as intelligent behavior, right? And creativity is just the same, right? So the way we deal with this is effectively to take the same, dare I say, workarounds that AI people have used to avoid trying to define what intelligence is. And we use them to avoid defining what creativity is. So we normally talk about, we say, an AI system is creative if it's doing a thing that we would deem creative if a human did it. Simple as that. Because ultimately the definition of creativity is not important. It's what the systems do that is important. Mm-hmm. Now, maybe if we can build a creative system, or if we build creative systems, because generally speaking, it's focused, it's not general, like your application of working out the intention of someone, which is focused. You can do it when it's a foot, but you can't do it when it's a whole person, maybe. We tend to break things down in that way to try to understand different aspects of creativity. And because creativity is so fundamentally a human thing, like intelligence, there's a sort of quite a strong interaction, I suppose you could say, between computational creativity, the creative side of AI, and cognitive science. So there has always been a strong connection between cognitive science and artificial intelligence for very obvious reasons. But in the case of computational creativity, it's kind of right in the middle, that connection. And so quite a lot of the work that we're doing is telling us about humans as well as about machines. Or at least finding hypotheses about humans, maybe.
Yeah. What do the systems create? Is it images, music? Is it other things?
So a random example, one of the most successful computational creativity systems was developed in 2000 by a researcher called Simon Colton. It is a mathematician that generates integer sequences. Okay, now maybe that doesn't sound very interesting to many people. but to mathematicians, or to a certain kind of mathematician, it's very interesting indeed. And it's something which only expert humans can do, which involves creativity. It involves being able to make the leap of seeing, that is going to be interesting, and then demonstrating it.
Yeah.
Right? Which is a classic thing that mathematicians do when they're being creative. They see the possibility of a theorem and then they prove it.
Yeah.
It's that seeing the possibility that's the creative part. So, that particular program has solutions that it created, new interesting integer sequences, and it explains why they're interesting. It doesn't just generate them. It has those which are published in the Journal of Integer Sequences. So in other words, competing with actual human mathematicians at the human mathematical level in an area which is fundamentally creative, even though it's mathematical.
Yeah.
But then there are systems that generate music. There's very famous work by a number of people throughout AI history, some better known than others and some more successful than others, of course. And we're increasingly seeing now digital audio workstations which have AI built into them for things like producing chord sequences and so on, so that there's the what you might call the basic boring stuff, maybe, for at least a composer who's working in the context of perhaps making music for TV ads or something like this. That could be done by the machine, and the human can focus on the more challenging and interesting stuff.
Yeah. I've had a few conversations about creativity now with the generative AI boom that we're seeing now, especially for people like me on the user side. It's suddenly become very visible. So I've had a few conversations with other people about, can AI be creative? The thing that for me I'm a comedian and a performing artist, so the thing that I think is creative work for me there is the ability to come up with a lot of possibilities, but also the judgment of what the good ones are to work on.
Absolutely.
And how does that work in a computer?
Well, this is the really interesting thing. So in order to do that, you have to have some notion of what makes something good. Yeah. I mean, the really nice example actually comes from comedy, where you can talk about something being a joke, and it's really easy to see, usually it's easy to see that something is meant to be a joke quite independently of whether it's a good joke or not.
Yeah.
Right? So you can identify the artifact, and then you can say whether it was what it was meant to be, whether it was successful in the way that it was meant to be. And this applies pretty much across the board in creative work. So, you can talk about a chef, for example, making a new dish. And you can tell it's a new dish. Then the question is it any good?
Yeah.
Right? So, and all of these any good questions have their own scales, their own levels of judgment, their own kinds of judgment, depending on the nature of the domain. So like AI, computational creativity is a very general thing. We're looking at trying to find general principles that allow us to model these behaviors. And we talk about aesthetics in the sense of, what makes something beautiful, what makes something good. But generally speaking, we appeal to human aesthetics because we don't know what it means to say that a machine has an aesthetic.
Yeah.
So generally speaking, when we want to make a distinction between generative work and creative work, we do exactly the thing you said, which is that we require that the system has some notion of choosing, of making decisions about what is good and what is bad and why something should be the way it is. And then ideally being able to explain those things, of course. It's a little harder to do. But not simply generating stuff.
Yeah.
Because let's face it, you can roll a dice, right? And you can generate numbers and you can make things in that way. But would we call that creative? We probably wouldn't, even if it's a human doing it, right? Mm-hmm. The decision to do it might be creative, but the act of doing it wouldn't. Yeah?
That's something that with the research I've been doing now for my theater show about AI. Something that I came across, so the AI systems can produce stuff, but a human artist, because of course in the artist world there's a lot of nervousness, some enthusiasm, some complete fear of generative AI, and a lot of discussions about is this art or not. I love them, they're endless. But so as a human artist, you could say you're kind of your own censor, because you can sense if does this do something to me or not, which a program like DALL-E can probably not. It can just base itself on what others have put as beautiful online.
So this is getting right into the center of what it means to be human, right? Because what you're fundamentally talking about there is the ability to feel.
Yeah.
And as far as we know, computers cannot feel. We've designed them pretty much so that they can't, right? Because there's no component to allow them to do that. So unless you believe that consciousness and feeling is some kind of supernatural thing that happens just because information is processed, and there are actually people who believe that, but I don't, then absolutely computers can't feel those things. But that doesn't mean you can't simulate those things. So you can build a model of what a human does and then apply that model. Now, the thing is, if you apply that model to a generation system, which is fundamentally different from what a human does, then maybe you're going to get new stuff, right? Maybe you're going to explore different parts of the landscape of possibilities and come up with new things, which the human-like mechanism will then say, oh, actually, that's quite good, but it's different from what I expected.
Yeah.
So then you can perhaps see a machine being creative in a way that a human would genuinely say was being creative without itself feeling that sense of novelty that you're talking about.
Yeah. One interesting question that I got from a musician was, can AI invent a new style of music? For example, the blues and jazz evolution, where you get new harmonies. Well, so they are new harmonies, but humans then had to decide, do we like this sound or not?
Absolutely.
An AI can be based on everything that exists. It can maybe come up with a new harmony, but can it then decide, is this going to be any good for humans?
Maybe. We don't know yet. That's where we're still doing the research, right?
So it's not a hard no. It's not.
It's absolutely not a hard no. But what I would say is, with machines as they are now, right? I'm not talking about future biological computers or quantum computers or whatever. I'm talking about the machines that we have now. I am completely convinced that they cannot make aesthetic judgments in the way that humans can.
I see.
Because that just doesn't mean anything.
Yeah.
That doesn't mean that they can't simulate those judgments. So they can't feel things, but they can say what a human would say, because we can build a mathematical model of that, maybe. And there is a whole field of computational aesthetics that works on that.
I see. Computational aesthetics, what a wonderful
so
word.
That's essentially trying to understand human feelings in this kind of context. Right?
Yeah. Oh, let's change art into numbers. They will love it.
It's not quite changing art into numbers. It's using numbers to represent art, which is a different thing. By the way, art is a rather special thing here. And maybe art is a dangerous term to use. I mean, there are lots of things that are creative that are not art.
I see.
And there are lots of things that are art that are not terribly creative too,
honestly.
And it doesn't matter.
Yeah, I see.
So I think it's quite a good idea to make a distinction between those two things.
Yeah, because then we lose a week with discussing about what art is, and here be dragons.
Here be dragons, indeed, and not computers.
Yeah.
Because making art is fundamentally a human decision, I think. You can use a computer to make art, but the computer can't decide to make art.
Yeah.
Because it can't feel, it has no aesthetic.
A documentary that I watched during my research is the AlphaGo, the movie, and the famous Move 37, of which Lee Sedol, the Go champion, said this was a remarkably creative move. The thing, what I think is very interesting there is that, of course, the decision of what a good move is or not is clear, because it's a game with the clear goal, so the computer has an easy time, you could say, judging if it is any good or not. Is that the difference with art then, that there it has this fixed rules and it has this goal, so it can be creative more easily?
It's one of the differences. I mean, that whole statement about something being creative is an interesting one. Because what does it mean when we say, "Oh, that was creative"? What it means is, I wouldn't have thought of that, right?
Yeah. Unexpected and good.
Unexpected and good, exactly. So you in the context of a game which has a defined space of possibilities, then it's always possible by enumeration, if you have an infinite amount of time, to consider all the possibilities, right? So then your program, if you have an infinite amount of time, is going to think about that. So a lot of the early AI work in games, the chess programs, for example, Deep Blue and so on, that was all about building a computer system which could simply look far enough into the future of the game so as to make the right decision.
Yeah.
So you could argue that maybe that is not the same as the human inspiration that helps a grandmaster see a solution in chess, whatever that means, or a mathematician see a proof.
Yeah.
We use this term that you see, even composers say, I see a piece, right? I think this suggests something quite interesting about what's going on in the brain. I think we're constructing representations of things in our minds, which we then fill out in a process of becoming more precise and more accurate. And I think that is actually probably a sort of underlying general creative process in very, very abstract and vague terms. And I think it applies in the context that you're talking about, because this particular grandmaster did not happen to have that particular vision in his vocabulary, to put it in very loose terms. Okay. I think there are other kinds of problem, and those problems tend to be artistic ones in general, where there isn't a clear metric as to when you've succeeded. So you don't win the game, or you don't complete, you don't finish painting the house or whatever it is. And that then makes the whole thing more interesting. And it also brings into question the things that are most commonly presented as generative systems in AI at the moment, because most of those systems work on the basis, this is a generalization, but generally they work on the basis of what we would call interpolation. That's to say, taking examples of things and filling in the gaps between the examples in some sense.
Yeah.
But what a really good human creator does is extrapolation. That's to say, they go beyond the range of what is currently possible.
Yeah.
Yeah.
Okay.
In some way or other. And so in order to do that, you have to have a different way of looking at the AI. You can't just be saying, well, I'm trying to capture my data and build a model of my data. Or at least if you are doing that, then you need to have some way of going outside it, whatever that means.
Yeah. So we were talking about it ranges from mathematics to ethics and society, but now we have an entire philosophical side to it, and a lot of semantics. I think semantics is the word that I'm going to use most here.
And don't forget psychology.
Of course,
Yes.
and even neurology, cognitive behavior,
absolutely.
all these things. So you're all working with AI in this AI lab on completely different fields. It's a big landscape. Do you often meet, or do you collaborate, or is it more each one on their islands?
Well, I've only recently started, so
it's true.
don't really know that much, but maybe Geraint can.
Yeah, we collaborate, certainly we do.
Okay.
We have our own thing.
Yeah.
But it's always a pleasure to work with other people, right?
Yeah,
so where we can, we do, absolutely.
Yeah.
Usually two heads are better than one.
Yeah, definitely.
So depends on the most of the
It depends on the heads to some extent, but yes,
But still,
most of the time it is.
yeah, and I think that's good that we're working on so different things. But if we would all work on the same things, then it wouldn't really benefit us working together.
Absolutely.
Yeah.
And it's always been a feature of AI that AI labs tend to be this broad church.
Already.
More so than in other areas of computer science, dare I say? I think I dare say that. Yeah.
Okay. Yeah. Well, it has changed a lot over the past years, I would imagine. When you started, were you already mainly working with neural networks, or was it more than this? Just that?
Not really neural networks. Like I worked a lot with kernel machines, like support vector machines is the most common one, and that might now seem like one of the old methods. But there's a lot of research still going on about it, and a lot of people that are really working on it think it will be the next deep learning, let's say, but let's see. But I feel like in 2014, when I graduated to Master AI, it wasn't that much all deep learning and neural networks, but a lot of it is now.
Yeah.
At least what's also in I would say media, but it's like specialized media, is a lot of that. But in research, if you really go to the research side, then there's a lot of things that aren't this deep learning or that aren't these neural networks, I think. So, yeah, I mean, it's at least what I see.
I completely agree.
Assume you see the same thing. Yeah. So we are working on a lot of other things as well. But it's, I think, a lot of the fancy breakthroughs of today are with these deep learning, but it's definitely not all there is.
I see. So there is this corner in the lab with grumpy people who are not into deep learning or look at all those hipsters with their media attention and
Actually, in our lab, it's the other way around.
Yeah,
I see.
Yeah. There's relatively little deep learning going on in our lab. Yeah.
Wow. Yeah.
We're people who've been established for quite a long time in doing other things, and for the most part, we haven't seen any reason to change what we're doing.
I see.
The deep learning work is fascinating and useful and very successful, but it isn't the whole answer.
See.
It's not going to be enough on its own.
Aha.
Yeah.
So this sentiment that maybe for people outside of the research, this sentiment like, okay, now it's neural networks and deep learning and they are the new thing to go and all the rest, this old stuff now, that's...
I think like a lot of times in AI we thought like, oh, this is the new thing and this will definitely be everything. And then after a while it turned out that there was some other thing that worked. I mean, I think now it's deep learning, but I'm not sure in 10 years if it's still be deep learning.
So,
or it at least won't be the deep learning that we have now.
Yeah,
Exactly.
Definitely not.
people who know their history of AI have learned that the sentiment of now we've got it is almost always false.
It changes every time.
Well, it's a fundamentally unscientific sentiment,
It's
right?
true, yeah.
And we are doing, well, we're trying to do science, even though it's an engineering science. So I think that's exactly right. The bottom line is you could always do better. And with something that we understand so little of as intelligence, then we to say that we've solved the problem is massively hubristic, to be perfectly honest, and not true.
Yeah.
So we're going to need all the guns we've got
Yeah.
in order to fight this one.
There is a lot of fundamental research that you don't see today because there may be also some other constraints that we don't take into account. Like I bring back to my initial statement, computational power or the way you compute things. You know, we are mainly focused on silicon base of computing stuff. But there are other ways of computing things. And if you manage to compute that, then a lot of the fundamental research can arise. And then there will be the new deep learning based for SVNs or for either other models that are out there. So
just like neural networks were something very obscure once,
Neural network.
promising but niche.
Well,
it was...
but we are currently on the third wave of neural networks.
Yeah, that's
right?
true.
This is the third time
Yeah.
the ship has tilted that way.
Yeah.
I see.
And I don't doubt that it will tip back again. And deep learning will continue, and it will continue to be successful, and it will continue to be very useful and do wonderful things like diagnose cancer and so on.
Yeah.
But it's not the only part of the answer.
And I think also a lot of the systems that come out now today are not pure deep learning anymore. They're usually combined with other things like symbolic AI.
Precisely.
Yeah.
So now we have neurosymbolic AI,
Yeah.
right? So there's even a name now for this merging of things. Science progresses in this way.
Yeah. You've seen a lot of the evolution since the 80s. So
Keep reminding me.
this lab started in 83, I think.
84? 83, whichever.
Yeah.
Around then, yeah.
Did you always work in artificial intelligence specifically or broader computer science?
So I started as a mathematician, then moved into computer science. When I was an undergraduate, it wasn't deemed that there was enough computer science to fill a 3-year course. So there was only a 2-year course. And I did that. And then I went into AI for my PhD. So I've been an AI person ever since then.
How is the current boom for you? Is it surprising that suddenly everyone is talking about it, asking you questions about ChatGPT and all that stuff?
Gosh, I could talk a long time about that. So, surprising, no, because one wouldn't be in the field if one didn't think it was going to be very successful at one point. Right?
Even this scale.
Frustrating, yes.
Really?
Well, for the reasons that we were just talking about, right?
Yeah.
Almost always it's necessary to talk about expectation management, right? It isn't magic.
Yeah.
And sometimes it's a little bit frustrating about the way AI is portrayed in the media in ways which are really actively damaging.
The Terminator robot with the red glowing eyes that they
For
always
example,
show.
really not helpful. I mean, it's very good that we have people warning us of the dangers, because there are dangers. Absolutely, there are. But the biggest danger of all is indeed believing that it's magic and it can do whatever you think it can. Yeah, that's the really big danger, because then you rely on it in ways that you shouldn't. Yeah. And I'm afraid there are quite a lot of journalists out there who don't do their homework and who give us that impression.
I agree.
If I bring the industry back, actually, because I'm now on the industry side, one example of that is regulation. Right? See, if people don't get informed correctly, they will start regulating something that will actually damage this research to actually reach the industry at its full scale. Okay. Right? It has to be regulated. It has to be that people has to be very well informed on what needs to be regulated and what should not be regulated, or even think about being regulated. So I think I agree with you, is one of the biggest danger is misinformation about it.
And do you mean for the general audience, or for the politicians, or for both? Maybe?
Well, basically both, because we choose our politicians. So if I'm scared, and then there is a guy who's actually, we need to regulate because the apocalypse is coming, then of course I would vote for that person. But at the same time, indeed, politicians itself, because actually I just read an article that almost 85 politicians believe actually that AI is very dangerous in terms of other things, that tomorrow we're gonna generate an AI that's gonna destroy humanity as knowing, and then.
But I must say, so I've been researching this topic now as a science communicator for 3 to 4 years. It's not easy when Geoffrey Hinton is very alarmed and Andrew Ng says it's the new electricity, let's chill out. So even that, so one piece of misinformation or misinterpretation was quite easy. I think the Terminator scenario, where the AI decides for itself out of some unexistent instinct, I want to dominate, that's something that we can keep an eye on, but move aside. But the Geoffrey Hinton scenarios, for example, like this is going to become so complex that we set it a goal and the methods are not aligned anymore. I don't know what to think if I see these experts disagreeing in their alarm phase, you could say.
Yeah, I understand. But actually, I'm going to give you... It already happened, but in a different field. Okay. In the field of nuclear power, for instance. You know, with atomic energy and then nuclear power, today we have a problem, you know, with energy. And because of the atomic bomb and all this misinformation, actually, on politicians, they stopped the development of nuclear power 15 years ago. And now is the moment that we may need it, but it's not yet ready because we didn't keep researching on it, because regulation stopped this movement, you see, because of misinformation. And I like to bring that story into the AI today. Look what misinformation can do on stopping the AI and the movement just because they believe it's gonna be dangerous because of this misinformation. And coming back to your answer, it's very difficult, but then that's up to research and education to try to bring people that look at these issues objectively, and to look at what are the possibilities, and then try to teach new students, try to teach the community about the real risks that are there on AI. Because okay, we are humans, we all have our opinion. Even if I'm an expert on something, that doesn't mean I have the full answer. And then you will always have different opinions from one side to another. But at the end, all it boils to, for people that are looking at AI, just try to look at different point of views, right? And then hopefully academia and so on accelerates a little bit in terms of trying to find ways of looking AI and impacts of AI objectively, and then hopefully that information will be brought to politicians to do the right
So
choice.
we can disagree in society, but we have to be informed, because if we disagree about things that we don't really know how it works,
Exactly.
then it's a discussion that is kind of useless.
But that already tells you that when there is information that no one agrees, then it means that I cannot regulate it. See, because you don't know what to do. Either I fully stop it or I fully leave it. Probably that's the wrong decision. So it means that people have to put effort in it. Actually, that's the message.
Yeah.
Okay, there is a gap. Then I need to put effort to ensure that I get all information that I need to make decisions. Yeah.
Is it a sentiment that you see among students too? The fear or the hope or are they more technically?
No, I do a workshop with the students in first year where they get an application of AI and they need to think about the ethical dilemmas.
Okay.
So they actually need to think about these things, about what can go wrong, and they also need to not only think about the things that could go wrong, but also how can we work with that? Not say we don't do this application, but let's see, can we limit some uses maybe, or can we make sure that we inform the users correctly, because that's very important. So I mean I do try to make them think about it, because it is good that we think about it. And so they do it very well, actually. They do it actually very well. Like I had this workshop and they came with ideas that I hadn't thought about. So it was very interesting to see. So they are thinking about that.
Hope for the young people.
I think so, yeah. And I also think that like in Europe, we are thinking a lot about these regulations. I mean, the AI Act, it's been in the work for many years already. I think in the US, they are limping behind a little bit. I think these things are important because the things that Hinton said, I mean, he's a smart guy. It doesn't come out of nowhere. And we have to indeed maybe do something about it. But I don't think that do something is don't do anything anymore with AI. I think that's...
But the psychological difference between Europe and the US is once again so interesting here. The fact facial recognition is an example that I use in my show. The fact that we say police cannot use facial recognition in the European Union. And then I would expect that in the coming years they would allow it for some severe cases, like shooter is on the loose. Then it's very interesting to have this on a public camera network. And then in the US they say, so we say new technology, we're not sure yet. Let's first investigate and then regulate and then slowly release it. And in the US, they say, new technology, that's fun. Let's all use it, see where it goes wrong, and then regulate it. It's kind of bottom up approach that we have there. Maybe we meet in the middle.
Yeah.
Could be.
Let's hope that the US has some work to do. But well, Europe as well. I mean, definitely not there yet.
But we've made a start, and that's the important thing. We're aware of the issue now, and we'll work towards a solution.
Yeah. But so the fact that I have a theater show about AI, I'm kind of helping the future. So they, good, now my work has purpose.
Yeah. I told my parents to go see the show.
Oh, okay.
Yeah, because I want them to know a little bit about it as well. And they listen, I think, more to you than to me. So.
And of course, we'll be there taking notes.
Yes, I'm being peer reviewed.
Yeah.
But it's good that for the journalists who like this picture of a robot with glowing eyes, they should just put a big mathematical matrix there instead. Like, this is AI, people, not the
Which is
robots.
way more terrifying.
When you're doing an exam, it certainly is. Thank you very much for this conversation. I'm just amazed by how much work you have. You all have your specialization, but no one is an island in AI, I would think. You have to have this broad view. And now, especially with the huge surge in generative AI and the public interest and the political interest and company's interests, you need more people, more students,
Yeah.
Exactly.
more people who know what AI is. I end my theater show with showing ChatGPT writing code, so I ask it to write code. And some people even some young people even come to me after the show and say like, well, you just showed that I don't have to study computer science anymore because it's all going to be automatic. And it's, no. People will drive the cars. Many people will have to build the cars and maintain the cars and make sure they are safe. So yeah. More students for the AI lab.
Yes.
That's the
Thank you very much for your insights.
Thank you.